Press cycle start. The machine moves to the start position and stops at the M00 line in the program. Ensure that the overrides are at 100% at this point. Load the Ballbar into position, making sure that it's properly seated. Click Cycle Start on the software. Press Cycle Start on the machine control to run the test. On the initial in-feed there, the Ballbar starts communicating with the computer. You can see the data appearing on the data capture screen. After the first 180 degrees, we start collecting data in earnest. We are now in the data capture portion of the test. Running in the counterclockwise direction, you can see the data appearing down on our data capture screen. The reason for the overshoot is to allow the machine to get up to speed and then to decelerate at the end. We're in the deceleration portion here. Modern machines actually can accelerate and decelerate much faster than machines 10 years ago, say. So it's really not necessary for us to have the 180 degrees, and you can program with a shorter overshoot if you'd like. We've started the clockwise data capture portion at this point now. And you can see the data appearing in the data capture screen. Again, don't let it bother you if the data does not appear to be centered. The Ballbar software automatically centers the data for you for analysis. By being careful about the placement of the cable and ensuring that there's adequate slack, you can make sure that the Ballbar test runs flawlessly. And this outfeed concludes the test. Notice the test summary, which indicates whether the runs passed or failed. Green box with a check mark indicates the runs were good. We're going to go ahead and save the data before we continue. Click on Save. Notice the unique file name, which is in accordance to ISO, containing the test criteria, the date and time down to the second. We can also modify this if we'd like. I will add test in front of it just for our reference. This will be saved in the Quick Check folder.